Okay, welcome everybody. This is live streaming onto YouTube. So welcome to the fun. We're going to get started in just a minute. We're waiting for one more presenter. Okay, welcome everybody. This is live streaming onto YouTube. So welcome to the fun. We're going to get started in just a minute. We're waiting for one more presenter. Okay, welcome everybody. This is live streaming onto YouTube. So, hey, are you guys hearing two multiple audio streams?
Yeah, kind of heard twice.
Yeah, let me see if I can figure out what's going on here. Just a second. Hey, welcome everybody. This is live streaming onto YouTube. So, hey, are you guys hearing two multiple audio streams?
Yeah, kind of heard twice.
Yeah, let me see if I can figure out what's going on here. Just a second. Hey, welcome everybody. This is live streaming onto YouTube. So, hey, are you guys hearing two multiple audio streams?
Yeah, kind of heard twice.
Yeah, let me see if I can figure out what's going on here. Just a second. Hey, welcome everybody. This is live streaming onto YouTube. Hey, are you guys hearing two multiple audio streams?
Yeah, kind of heard twice.
Yeah, let me see if I can figure out what's going on here. Just a second. Hey, welcome everybody. This is live streaming onto YouTube. Hey, are you guys hearing two multiple audio streams?
Yeah, kind of heard twice.
Yeah, let me see if I can figure out what's going on here. Just a second. Hey, welcome everybody. This is live streaming onto YouTube. Hey, are you guys hearing two multiple audio streams? Hey, it looks like, hey, Igor, it looked like one of them was coming from you. I just muted you. I'm trying to sort out why we're, okay, looks like we're dying out. Let me,
Hello.
Hey, we're having a problem with the YouTube live stream. Just one moment here. I will get back to you. I'm getting an audio feedback.
No worries. I'll go off camera till we're ready.
I think I found it. All right. Okay, I think I got it. Let me go back to, let me go ahead and open this stream again. Hopefully I didn't lose it. Sorry about this, everybody. Sometimes YouTube is a little bit wacky. Let me get, and we'll jump in. Our speakers are here, which is great. That's totally awesome. We'll get going in just a second as soon as I can get back into the channel and make sure that we're streaming. Okay, looks like we're live. If there's anybody watching the stream, if you can, I'm just going to ask for a confirmation that folks are seeing us. And I'm going to go ahead and start my audio so you can see it. All right, I'm going to go ahead and resume recording. We'll be recording this and we will also be streaming to YouTube, so it's doubly recording at this point. All right, let's get going. So welcome everybody. I'm glad to see you all. Looks like we've got a number of participants on the webinar and a number of people, at least a dozen people on YouTube. So it's great to have you here. I'd like to welcome you to the Bay Area, the SF Bay Area ClickHouse Meetup. It is my privilege to introduce a couple of great talks on the application side of using ClickHouse. But before we get into that, I'd like to go ahead and just give you a little bit of background on this so that, you know, in case you haven't attended this before. So I'm the CEO of Altinity, and I'm one of the organizers of this meetup. If you haven't heard of Altinity, we're enterprise providers for ClickHouse. So we help people run ClickHouse, pretty much do anything they need to run ClickHouse. We have a managed service for ClickHouse in the Amazon cloud. We also offer support. We do a lot of NRE on, that is to say, engineering on ClickHouse itself, and we also offer training. We're total database geeks, and I have with me today, I'm happy to say, Denis Shiravlev, who also goes by the name Danny Crane if you're out on Telegram. He's coming to us from New Brunswick. I'm coming to you from Berkeley, and so we'll be your hosts today. Just a little bit about future meetings and other announcements. We'll do the next ClickHouse meetup in June. We're trying to do them at basically at 2-month intervals. I'm looking for talks. So if you have ideas about cool things either you'd like to hear about or that you would like to talk about, please let me know. You can contact me directly through the through Meetup. You can also come on the Slack channel or come to Telegram. You can basically find us out if you want to do a presentation. If we don't hear from people, we'll probably default to doing something like performance. People never get tired of that. So that's definitely a topic that we haven't talked about in too much detail recently. So look for something probably early June. That'll be on your calendars pretty soon. And speaking of talks, one of the things that's coming up soon that we're helping with is Percona Live. So if you haven't heard about Percona Live, it's a conference for open source databases. I've been going there for about a decade. In fact, more, probably since it is sort of the follow-on conference to the old MySQL conferences. It's run by Percona. And we are running the analytics track this year. So that's us as in we as in Altinity. And we're looking for analytics talks. The call for papers is another couple of days. If you have a cool story about building any kind of application on top of open source analytics, it does not have to be related to ClickHouse. We're looking for any analytic databases. It's just if you're open source, if it's an open source story, we'd love to hear it. So the details for that are on the Altinity blog. If you just go back and look at our posts, we provided the details, and you'll just have to go ahead and fill out the paper proposal. We'll look at all of them, and we'd love to have you present. That's coming up in May, and it's a great opportunity to get in front of a lot of open source people. I think the last conference they had something like 10,000 people sign up, so it can be pretty big crowds. With that, I'd like to dive in, and let's go ahead and let me pull up see the order we've got here. So, oh, interesting. Looks like Meetup is getting a, I was just pulling up the agenda because I had to delete it when I was trying to sort through this problem here, and I am getting a 500 error. Let's see if it comes up. All right, looks like it's working now. Great. So we've got two talks today. We've got Abe Gong and we've got Igor Lukanen. I'd like to welcome both of you. It's really great to have you here. And so what we'll do is go ahead and kick the talks off. Actually, before we dive in, there's one thing that we like to do when we don't have a huge number of people, which is to invite people to just speak up and introduce themselves. We've got 17 people attending. We have a bunch of people. We have something like another 15 or so running on YouTube. I'm going to go ahead and just allow everybody to talk. And if you want to jump in and just say who you are, we'd love to have you just tell who you are, where you're from, and then we'll jump into the talks. So let's, don't all jump at once. I see like Aaron Harsh, if you want to talk. I'm just looking at alphabetical order. If you want to just unmute yourself and say hi.
Sure. Hey, Robert. Hey, I'm Aaron Harsh. I'm a software engineer with DuckDuckGo. We use ClickHouse internally for some of our analytics, and I'm excited to learn a little more about it.
Cool. Welcome. Great. Got David Swift up next.
So I'm David Swift. Love the picture there. I should get a good one someday. The company I work for is called OnFleet. We do not currently use ClickHouse there. I've had a hankering for a while to create an adapter for ClickHouse on a monitoring project called Bosun. And I've just been following it for a few years. So
Cool. Great. Glad to have you. Ray, looks like you're queued up next to talk.
Hi. Hi. My name is Ray Peck. I actually work with Igor at CubeDev. I'm head of community. It's nice to be here and nice to hear the words analytics plus open source.
Excellent. Great. Yeah. Well, if you want to, you heard the offer to come talk at Percona Live. So if you want to expand on that topic, we've got a forum for you. Looks like we got Timur up next.
Hi, my name is Timur. I'm a senior DBA at Five9 company. We use ClickHouse for internal analytics. It's not some production system, but we use it for analyze some data.
Okay, great. Let's see. Next one, Paulo. I saw Paulo.
Oh, hello. Well, I'm data engineer in Brazil, and we very much like ClickHouse and all the comparisons with other databases. But you were just talking about other talks, so maybe we could talk, not me because I don't know how to do it, but using Kubernetes to go to many clusters of ClickHouse, you know, and this replication and these things, you know, because we needed some time ago, and this could be a suggestion.
Cool. Would you like to hear that talk or would you like to do that talk?
I like to hear because I couldn't do it.
Okay, so that's ClickHouse. So what you're saying is ClickHouse on Kubernetes. Did I hear that correctly?
Yeah, replication and all this.
Yep. Okay. Great. I noted. We love Kubernetes, so we'll come back to that one. Cool. I see Namdi. Namdi, you want to? Hey, welcome.
Hey. Good to see you, Robert. Name's Namdi. I'll just keep it short and say I work in venture. I won't say at what firm, but super big technical nerd and curious to learn more about the technology here. And hey, Ray, nice to see you or hear you, I should say.
Small world. Hi, Namdi.
Great. Okay, so who else anybody else want to sort of speak up? You don't all have to. If I see anybody unmuted, anybody else who wants to unmute and say hi? All right, I don't see anybody. I'm going to dive into the first talk. So we've got Abe Gong from Superconductive. So Abe, if you want to go ahead and do a share on your screen and make sure that comes up okay. I'll tell a little bit about how I know Abe. He's working on a project called Great Expectations, which you're looking at. And this caught my attention because I love testing. I used to do it for Sybase. I was in QA on the Sybase products for about 5 years, and it's a totally interesting topic. But Abe is doing something really interesting around what you might call data contracts and data cleaning. And I'm going to let Abe explain everything else. So take it away.
All right, thanks, Robert. Thanks everybody for being here. I'm coming actually with a lot of questions because the last time that I spoke with Robert and the folks at ClickHouse, we realized the people using Great Expectations have a lot in common with the people using ClickHouse, but aren't necessarily exactly the same communities. So this is sort of a bridge building exercise to see like how much can these two tools work together. And so I'm gonna have some questions for you. A little bit about me. I'm coming from a data science, data engineering background. Not typically an application developer. I've done a little bit of work on platform, but typically working downstream from that. And Great Expectations comes very much out of that experience. I'll tell you more about it in a second. On our side, so I'm the CEO at the company Superconductive, which is the company that's supporting and taking Great Expectations to market. We're hiring, so if you're an awesome software engineer, we'd love to talk to you. Enough about that. Outline. So I'm going to cover 3 things here pretty quickly. One is, what is pipeline debt? I'm going to talk about technical debt in the context of the data world. Again, curious to get your reactions on this because it's a little bit different than the software world. And I'm going to pitch this to you in the same way that we usually talk about it with data analysts and data engineers. And I'm curious about what makes most sense to you and where you see differences. After that, I'm going to talk about Great Expectations and how we have built it as a tool to solve technical debt in data pipelines. And then last, I want to talk a little bit about potential integration and just understanding how you're using ClickHouse, how you're thinking about data testing, data quality, and so on, with an eye towards possibly integrating the two more closely in the future. So let me dive in. What is pipeline debt? So species of technical debt that inhabits data pipelines. And like all technical debt, it's mainly a result of missing tests and documentation. When I talk about this with data engineers, less software engineers, not so much software engineers, here's how we usually talk about it. So we say, if you were a software engineer and you were developing an API and you went to your stakeholders and said, hey, I've developed this awesome API, totally ready for you to use, would love for you to give it a try. However, there are some limitations to it. So first, it's not documented. We just we didn't have time for that. It didn't seem like it's that important. It's also not tested. So like the code runs, trust me, but we haven't actually tested this thing. Oh, and by the way, it might change at some point in the future, and I won't even be able to tell you when that's going to happen because we have other dependencies. So this thing's just going to break sometimes, and we can't tell you about that ahead of time. If you tried to pull this fast one in the software engineering world, people would look at you and say, you are absolutely crazy. Like you've got a nice prototype that's not actually production code yet. You need to document it, test it, and yeah, it definitely needs to be stable. However, if you go into the data warehousing world, you make just one little substitution, and instead of saying an API, you say, hey, I have a critical table in my data warehouse, but it's not documented, it's not tested, it's not stable. For some reason, data engineers have got to buy on this one for a long time. And I say this with love coming out of that community. Most of the world's data systems today do not yet have great testing. And most of the world's data systems today have some kind of documentation in an outdated wiki, maybe, or maybe in Atlassian somewhere, but like it's chronically out of date. Nobody ever like fully trusts it. And yet somehow we've all got used to that. So I put it to the data engineers of the world that this is craziness. Like living in a world like this is just not going to work. So punchline is trying to maintain a system like that where there isn't testing or documentation or stability is just crazy. It's just never going to work. All right, so that's how we talk about it with data engineers. Let me talk about the kind of specific technical solution in Great Expectations. We do a few things. So the first thing is we have a concept called an expectation, and it's an assertion about data. And if you're up on your testing, you'll note very quickly that I've done a little bit of a sleight of hand here. This is not tests on code. This is tests on the data itself. And the reason that we believe that's the right approach, not necessarily fully complete on its own, but the right way to start in the data world is in data pipelines, you don't control your incoming data. And most of the change tends to happen there. So if you want to test what's changing, yes, you can test the code, but it's actually usually more important to test the incoming data and then also test data at various stages down through your pipeline to make sure that it has the right properties along the way. And those properties are going to be things like expecting columns to exist, expecting the number of rows in a given table or a given batch within a table to fall within some range. We can also do tests on uniqueness, nullability, ranges, regexes, all kinds of things, actually. And getting up into kind of more statisticsy, sophisticated things, you can also do things like statistical process control. So making sure that the mean of a table or of a data flowing through a table doesn't deviate too much from your expectations. And other things like expect the histogram of your data to be close to, according to KL divergence or some statistical test, close to some expected distribution. So it's a really nice abstraction. You can fit all of these different types of sort of like schema to content to statistics all under the same framework, and they all work really nicely together. What that does is the same thing that tests do in the rest of the world. It lets you bend the maintenance curve. Instead of having this slow creeping complexity that you have to deal with that can easily get ahead of you, it allows you to really kind of push down the amount of time that you spend maintaining things because their intended behavior is declared and because the surface area for bugs is segmented throughout your pipeline. So it's not that it will completely free you from maintenance, but it'll make that maintenance much more predictable and much more manageable. And this has been a topic of fun conversations between Robert and I for a while. But that's not all. There are a few, actually, let me pause there. I think it's possible to ask questions, although I'm not totally familiar with the interface. If you have any questions, can you, go ahead, Rob.
Yeah, let's post them in chat. So there's two ways. I'm watching everything. So if you're on YouTube, just throw them into the in as comments on the in the live chat. Within Zoom, if you're on Zoom, just put them into the chat box because then we can all see them. Or you can just speak up if you're unmuted. So feel free to just jump in and ask.
Cool. And I'm going to be doing these sort of long, awkward pauses just to make sure everybody has a chance to get back to their keyboard and respond. If there's nothing so far, I'll keep going. Beyond just testing, it turns out you can do some extra pretty cool things with this concept of an expectation. So one is you can also solve the problem of documentation. And the way we think of it is your docs should be your tests should be your docs. There's no reason for those to be separate artifacts. And so Great Expectations makes it possible to compile all of your tests into human readable documentation. There can be multiple formats for that. There are like multiple build targets. But at the end of the day, because everything's declarative, you can always convert that through into human readable documentation. And that allows you to say to your data stakeholders, hey, you can finally throw out the old out-of-date wiki and trust that it's always going to be up to date because we're actually running the docs as tests whenever data flows through the system. A second thing that we can do is automated data profiling. So most software tests, I think you'd be very hard put to generate them automatically. And I don't want to overclaim. It's not that you can generate anything that you care to know about your data automatically, but there's actually an awful lot of information that's latent in the data itself. And so using a data profiler, you can go through and build a reasonable set of rules for boundaries and matching conditions and just kind of what has the past shown us. Maybe that's a good guide to what we should expect in the future. You can learn a lot that way. And again, it's a nice feature of this notion of declarative expectations. It's sort of a common language. Last thing in Great Expectations is we've built in all of the tools to be able to do batteries included setup and configuration for a data validation, data monitoring stack. That's all available in open source. There will be a commercial product that makes some things even better, but you get a lot of value out of it just in open source today. So let me pause there. Again, please feel free to jump in or ask questions, but Great Expectations brings a few new things to data testing. The first is this notion of an expectation and the ability to assert things about data. The second is to keep those in sync with your documentation through this compile to docs functionality. The third is automated profiling to help you build those test suites and documentation without having to write every single line yourself. And then finally, this batteries included config and setup. So long pause, questions, clarification.
I got one. Maybe you're going to cover this later, but you're basically introducing schema on data in effect because you're putting conditions on it. So how do you deal with schema migration? Is that something if you're touching on it later, you can go then, but I'm just curious.
So I'd argue that this is actually more than schema, or well, it depends on which notion of schema you're looking at. But for example, the sort of schema that you would define in a typical SQL database is like closely aligned with expectations, but not exactly the same.
Correct, but I think you have something. So for example, let's say that you drop a column. Just to take a really simple example, is there a way to, and you'd sort of expect to see that flowing through from the upstream source down to the database. From my experience of building these pipelines, this is one of the biggest single problems that you have to deal with. And so I'm just curious how you can, sort of go with the flow and not require people to go make a bunch of changes that make their migrations more complex.
I see. So yeah, I think the way that I'm seeing our more sophisticated users dealing with that is by using a version of a profiler that actually looks at the schema to keep the tests in sync with the schema itself. So it's actually very much like data migration tools. We see a similar thing with things like JSON schema, for example. Like sometimes you'll have data that's coming in and has form validation, and you want to make sure that the form validation at the top is kept in sync with the kind of contents of the data deeper in the pipeline or deeper in the data warehouse. And so yeah, like the notion that you can use automated tools to keep that in sync can help. It doesn't mean that like everything happens automatically, but because it's all being explicitly declared, you can operate on top of it that way.
Cool, thanks.
Igor is asking, so is it correct to say that Great Expectations is bringing property-based testing to data? Yeah, I think that's a fair way of looking at it. You can actually put several lenses on this. Like you can think of it as a progressive typing system for adding not just schemas, but kind of like stricter types to data fields over time. And you can also do some interesting things with like cross-table expectations to make assertions about how not just an individual field or column, but like multiple fields relate together.
Hey, we got one coming from YouTube. Is there any from Chris Leonardo? Is there any capability for data type coercion or schema-based transformation rather than just validation?
So we don't have that in the open source library itself, but it's pretty straightforward to build those hooks. And when I say straightforward, just want to caution, automatic data transformation, when it works, it's absolutely magical. When it doesn't work, everybody will hate you. So just like be very, it's actually one of the reasons why we have not tried to take on that problem ourselves, because doing the right thing in all cases is actually very hard. So we make it pretty easy to set up hooks so that you can tie in your own logic and your own transforms there if you choose to, but we don't typically own that part of the workflow.
Cool.
Cool. So let me turn it around. I have some kind of like feelers and questions I'd love to put to the ClickHouse community. So my understanding is, and I'm getting a little bit more of this from the intros, is that most of the folks in the room here are not data warehouse engineers, are not typically deep in the stack of building pipelines. Instead, you're living closer to the application development side of things, so kind of upstream from the world that I'm coming from. Living in a world where scalability and real-time or very close to real-timeness is super important. And so I'm curious where, if anywhere, you see strong potential for Great Expectations. And just to put this in kind of like reference two things. One is when we talk data engineers, we almost always show DAG diagrams like this, because thinking in terms of directed acyclic graphs and flows of data is very much the world that everybody there is in. I think people in in that world are less used to thinking in terms of APIs and microservices and more used to thinking in terms of flows like this. So kind of question for the crowd, weigh in however you want. Is this a framework that you tend to think in? Or do you tend to think more in microservices APIs? Polling the crowd.
You know, Abe, if I can jump in, the thing I hear a lot, and I'd be curious what other people think, is Kafka is, you know, there's sort of just this practical issue with connecting to a bunch of stuff coming through Kafka. And I don't know how people think about those formats. But that's sort of like, I see this big Kafka pipe. We see this constantly where people are reading off Kafka into questions. Into ClickHouse, and then being able to, you know, have some control over the data that's coming in. So that would be kind of a practical issue.
Got it. Yeah, I mean, from our last conversation, I'm still trying to figure out if I think about ClickHouse as sort of much more scalable Postgres or much faster Snowflake, if that makes sense. And like, I know those two things could look similar, but the way everybody's using it, yeah, could vary. Let me put another idea in. One thing that we often hear in the data engineering world is data changes hands multiple times as you go from source to ingestion to transformation to machine learning or dashboards or what have you. And so it's not uncommon for a given analytic result to depend on this big upstream watershed of other data sources. One of the ways that we see great expectations used pretty aggressively is this notion that we're starting to call data contracts. So at the boundaries between teams, you want to have SLAs for data quality. You need shared expectations between whoever's producing the data and whoever's consuming it. Sometimes that's more than one team using it for different purposes. And so you need to be able to have a concept of multiple stakeholders. And then on top of that, having collaborative workflows for triaging unexpected data or updating expectations together. And Robert, I'd include database migrations as one of the ways where you'd want to update expectations together. This is the thing that we're starting to see used pretty widely. I'm curious if this is a pattern that folks in the ClickHouse community are seeing, either emerging or needed.
While we're waiting for people to weigh in, there were actually a couple of responses off YouTube to your previous round of questions. One person said they see things as data flows between microservices. Another one said they see things as microservice APIs. You know, sort of that was the way they thought about the communication.
Got it. Interesting. So it's microservices that provide the foundation for streams. Then.
Yeah. Yep.
So regarding this data quality question, if we talk about big data, sometimes it's very hard to say what data is correct and what is not correct. That's the problem. And sometimes it's very easy to make a mistake in ETL, for example, and find it. Really, for me, I don't know how to catch those problems, really, because we have so much data coming in.
Got it. Yeah, I think one issue we run into a lot is correct according to whom, because there's the upstream producers of the data, there are people doing transformations, and then maybe multiple use cases downstream. And just keeping track of what everybody is using it for itself can become a problem.
Abe, you've got a couple comments in the chat from Paulo and Aaron. Can you see those?
Yes, I can. So Paulo is saying, I would put great expectations on my Airflow DAGs and workflows. Is this what you're talking about? So yes, absolutely. We have a lot of Airflow users also using great expectations. And then Aaron is saying, since no one else is speaking up, I'll give my thoughts. Our ClickHouse data is generally just some straightforward translations on top of log data. This makes the DAG simple enough that we don't run into many of the issues that Abe described. Yeah, that rings true to me as well. You'll sometimes see cases where Basically, like, if the data is simple enough and not being used by a lot of people, there just isn't room for that much complexity there. And so elaborate testing might not be that important. I don't want to assert that this is a tool that everybody needs to use everywhere. Like, it solves a specific set of problems around complexity in data pipelines. Oh, I'm seeing one other in the QA.
Yeah, exactly. That's from Denise. Yeah, I just want to make sure you saw that.
Okay, so we're mainly working with data processing, similar way to your background, but it was not clear what Great Expectations brings in comparison with built-in custom-coded scheduled checks of data quality. Can you elaborate more specifically? Yeah, so like at a surface level, I think we're doing the same thing. We're doing scheduled or on-write checks for data. The things that we're adding are, one, ability to build documentation from the data. I've talked to a lot of teams who have built custom checks for themselves. Very, very few who've taken the next step of making that compilable to documentation as an artifact that can be shared to other people, either on the team or outside the team. The other place where I think we can add a lot of value is with data profiling and helping to build the tests just kind of like efficiently, and then manage those, almost like assistance for keeping your tests in sync.
Hey, Abe, we got a couple comments coming in on YouTube. And one thing I want to do a time check. Just how much longer do you think you'll need to run, including questions? Because I want to make sure that Igor gets on and has enough time.
Just a few more minutes. I've got a couple slides for recap.
You're in great shape. So here's a couple more from comments from YouTube. One from Garrett, who says the way data is used in an application is not usually the way it's stored. That was a point. And then there's another one from Chris Leonardo. Are there points of integration built out for Apache Atlas or other popular data governance and metadata management frameworks?
That's a great question. I am not sure about Atlas in particular. We are seeing people start to tie Great Expectations into things like Atlan or Data Hub, so some of the newer open source tools. I know there has been interest in Atlas, but I haven't personally built out the integration, and I'm not sure how far the community has taken it. But we can look. That's actually a good segue. We have a very active Slack community. I'll share the link at the end. But if you have questions like that on specific integrations, that'd be a great place to take it. To the point about the way data is stored is often not the way it's used. There's actually a lot there. I guess I'll say yes. And the way that we think about it is, you typically, as a deployment of Great Expectations matures, what you typically see is expectations being fit to purpose, meaning the same data might have different teams applying different expectations to it, because a machine learning team is going to use it in a different way than a dashboarding team is going to use it in a different way than a bug tracking team. So yeah. Okay, this is helpful feedback. I really appreciate everybody speaking up. I know it's sometimes hard to do in a virtual meetup, but like good for kind of building common knowledge here. So we have discussed most of these things, and since we're tight on time, I think what we can do is we'll share the slides. I'd love to invite feedback like this in either to me directly or in the Great Expectations Slack channel. And the real question that I'm looking at is, are there capabilities that would make Great Expectations particularly useful for the types of deployments that we're seeing with ClickHouse? We've set it up so that it's not too difficult to extend to integrate the tools more tightly. Robert and I have been talking for a few months about how it feels like there should be something there, and we just want to put it in front of the community to see if there are helpful use cases. So some kind of a partnership or like open source contribution there would be helpful. We'd love to help support. Oh, Robert, I think you're muted again. Yep,
got a question from YouTube. Are validations running on the entire data or a sample? How does it scale with big data?
I'm glad you're giving me an excuse to talk about it. We have some fun undocumented features that allow you to downsample. Undocumented mean they're in the code, they're released. We just haven't fully documented how to get the most out of them. That's actually a use case that I would love to just collaborate on and advertise more, because especially for big data, that's going to matter a lot. The other thing I would say is often, not always, but often, it makes sense to not validate a whole table, but to validate the incoming slice of data within an hour or within a day. And we do have good facilities for that.
Yeah, I would think that the validation would have to do incrementally, like the ingestion of the big data, you know, because you do a, I don't know, a count in your S3, all the data, it will not be good, you know.
Yeah, that's right. Well, you usually want to validate on change. So as new slices arrive, that's the right time to do it anyway. Sometimes you want to go back across all past data and look at things, but that's a pretty heavy operation, right? Like a Spark cluster backfill or something like that.
Yeah.
All right. So just to be respectful of time, let me recap real quick. I'll give you my contact information and looking forward to continuing the conversation in whatever way is useful to you. What is pipeline debt? It's technical debt just like everywhere else, but has a little bit of a different flavor in data pipelines. We're getting to the point where it's just not sane to build data pipelines that aren't tested and aren't documented. And so we provide good tools to do that. Looking forward to seeing if there are good ways that we can use these tools together. And again, want to support open source and communities growing together. So thanks. Here's the address for the Slack channel, and looking forward to hearing from you.
Hey, thanks, Abe. This is great. I do have just kind of a dumb practical question. If you look at great expectations, I know for, I mentioned Kafka integration. A lot of us just think in terms of practical integrations with tools. Are there particular tools that you are closely aligned with? And if so, what are they?
So I think the place where most of the community has built out is first data warehouses and Spark. So Snowflake, Redshift, BigQuery, Spark. And then on top of that, we're seeing a lot of use alongside what I'll call like DAG orchestrators. So Airflow is the biggest. DBT, I think, is close behind and like catching up in the SQL world. And then there's some other cool tools being developed there, like Dagster or Prefect. We also see a lot of crossover with those tools.
Cool. Any other questions? Oh, let's see. Here you got one in the chat. Is the validation on the, I don't know if you got this one, is the validation on the SLA schemas open source?
If I'm interpreting the question correctly, yes. So all of the expectations are in the open source library. You can also develop your own if you want to, and don't have to share them if you don't want to. When you run them, Great Expectations, it essentially compiles it into Spark or SQL or kind of whatever execution you're running it in, and executes it against that engine. And we have lightweight orchestration of that in Python, but all of the data stays wherever it starts, and all of that machinery is open source.
Cool. Hey, thanks a bunch for a really interesting talk. And I'd like to invite people to, if you think there's a link here that could be worthwhile to ClickHouse, feel free to contact us as well at Altinity. We're just very interested in anything that can make pipelines easier to manage, and really stoked about the work that Abe's team is doing to solve this problem. Yeah,
thanks everybody. Thanks, Robert. Looking forward to hearing from you.
Excellent. Great. I'm going to go ahead, and since you've killed the share, Igor, if you want to just jump in. Before I do the intro to Igor, let me say that we will have time at the end, I'm pretty sure. So if you're here because you have questions about ClickHouse, and we'll hang around for a bit and entertain random questions about how to solve particular problems. So keep those, sort of mark those down, and we'll get to them. With that, I'd like to introduce Igor Lukanen from CubeDev. I met him out on the ClickHouse Slack channel where he introduced cube.js, came up in a conversation. It sounded really cool. He's going to be talking about querying ClickHouse via an analytical API with semantic layers. So Igor, go for it.
Yeah, great. Thanks for having me here, and let me share my screen so you'll see some slides. So yeah, the talk is called Querying ClickHouse via Analytic API and with semantic layer, but I promise you I won't go like more serious than that, and it'll be fun. So yeah, let me introduce myself. As Robert said, I'm a developer advocate with the cube.js team, but it is also correct to say that I'm obsessed with all kinds of data-powered applications. I really like data analytics, and probably the best way I can spend my weekend is just to try a new data visualization tool on top of some great data set. And what really brought me here is not my thick Eastern European accent that originates to the place where ClickHouse was originally developed, but yeah, this publication on Dev, which describes how one can build an application with ClickHouse and crunch some stock market data. Yeah, actually, I was building something like this to explore what was happening on the stock market during the recent events of GameStop, or what was called Wall Street Bets and things like that. So yeah, these candlestick charts are powered by many millions of intraday data points stored in ClickHouse and queried with cube.js, and we'll know about how to do that more in the future. But actually, my previous exposure to ClickHouse was a few years ago when in a company where it was used to replace the old-fashioned Whisper database in the heart of Carbon Stack, which was Carbon Stack based observability system, which was used to collect metrics through thousands or dozens of thousands of microservices. And after we introduced ClickHouse instead of Whisper, everything just started to work blazingly fast. Maybe it's not a really a use case that you'll come across often in the ClickHouse community, but anyway, that's a great use case, and you can actually find a link to a talk about this kind of about this use case on the adopters page on the ClickHouse documentation. But today we're going to explore how can you ClickHouse community fellows make your lives better and get some new powers through cube.js, which is an open source project I'm involved with. And when I was thinking how to introduce you to ClickHouse, with what words and with what ideas, I decided that the best way to do that is to talk about the ideals and behind ClickHouse. So as we all know from ClickHouse docs and from our experience with ClickHouse, it really shines when you run analytical queries against it and base your application on top of ClickHouse and make it query it online. So I can use the same exact words to describe the ideals between cube.js, with the only change is that cube.js tries to bring this operational queries and low latency and high concurrency to practically every database on the market, which supports SQL, and this is the only requirement. But so probably I shouldn't be talking much about performance and how to make your queries run faster, because if I ask if there's anyone here who's unhappy about ClickHouse performance, probably yeah, I know what would I see. I can't see any hands raised, so probably everyone's happy. So yeah, as we all know from the creators of ClickHouse, it doesn't push the brakes on your application. So so that's not really the concern we should be talking about. However, I'll take a different stance here. If I believe that some of you might be aware of this long read, really huge and really brilliant blog post by Alexei Milovidov, which tells how to explore GitHub data on a data set of more than 3 billion records, and it has some complex, not so complex SQL queries, which can reveal pretty much everything about GitHub, and I just took this one as an example of that. And here you can see some pull request comment events are being like filtered and grouped to reveal what are the pull requests with the most number of people who commented on them. And if we try this request and we run it, say in the Altinity playground, which is available like freely with this demo account, and which contains this more than 3 billion row data set about GitHub with GitHub events, we'll get the results. But if we try to reason about that query, we will be thinking more not about this like different functions being run, different SQL statements being put here, but more in terms of pull request URLs, which is the first line here, or just approximate count of users which commented on that, just like I was saying it before, and about like a subset of this event data set which contain pull request commands. So wouldn't it be nice for us not to use this like handwritten tricky SQL statements to reason about our data and to query it from our applications, but instead use some high-level business-specific, or I may say domain-specific language to query the data and operate on that. In my opinion, it would be nice, and this may be a very bold statement, but I would say that SQL is below our expectations if we try to reason about SQL as just something placed on the ladder of abstraction. Often we want to use this human-friendly or developer-friendly or business-specific queries or business-specific ways to describe what we want, what insights we want to get from our data, and actually you can do that with cube.js. So a cube.js query which results in the same data being queried from a database would basically look like this. So with the exception like with a few like brackets and punctuation signs, it's basically the same query. We say that we want to know all pull request URLs, and we want to know the user count for every one of them, and for these measures to be calculated, we only want to query a subset which of the events which contains pull request commands. So this query, so to make this query work, we would need some kind of data schema defined over our raw data placed in our database. So the data schema really is a set of like business-specific definitions which you operate with, and it really allows you to reason about your data, not in terms of function being called in SQL like concat or unique or something, or SQL statements like where or group by, but more in terms of what measures you want to calculate on your data and what dimensions you want to be present in that data. And this allows you to reuse your code and to eliminate code duplication, but more importantly, it can serve as a single source of truth for the whole your team, or to be the single source of truth across all your application, and to enable and to be able to run that query, we'll need a data schema, which is as simple as that. As you can see, we're still dealing with SQL here, but their dimensions and measures and groups of filters, which are called segments here, they are like separated, and they can be reused if we want to make another query which should pull the same data, but also also include some more measures, some more dimensions. So it's demo time. I'm going to show you how to actually launch and bootstrap a cube.js application on top of a publicly available ClickHouse instance in Altinity cloud, and how to make the same query that I was showing you just a few minutes ago. So yeah, I'm stepping into some dangerous waters here. Something is guaranteed to break. So let's hope that that everything will be smooth. So yeah. Here's the query that we're going to run through cube.js. So yeah, it's in a playground from Altinity Cloud. I have just rerun it, and we can see some rows here. Yeah, everything works great. It took about 1 second to run this query, and let me see. Yeah, and it had to process more than 50 million rows here. Okay, so how do we start? I go to cube.js website and just copy this command. So we're going to bootstrap some template application. Let's call it Hello ClickHouse, and configure it to connect to the ClickHouse and Altinity cloud, and then we'll add the data schema, and we'll use it to write some queries, and they will get like even more complex than we saw on the slides. So here, yeah, we need to install some packages. We need to say that we're going to be working with. Oops, sorry. Yeah, something was guaranteed to go south, and it really went. So yeah, I'm going to start over, because I just accidentally clicked on not on ClickHouse driver to be installed in this app, but on Redshift driver. Cube.js supports on lots of databases, like yeah, ClickHouse included, but also like Postgres, MariaDB, BigQuery, Athena, and a lot more. So yeah, it's ClickHouse right now. So yeah, we'll need a few more seconds. Yeah, and here we go. So we have this folder with just a few files. The cube.js file is the main configuration file, but as you can see, it's just empty because we don't need any configuration to to work with ClickHouse. And just one thing we need is to put some credentials in the environment variables. So I'm gonna remove the default file here and copy the one I've just specifically prepared for you right here. So yeah, this .env file just contains some basic network credentials for the publicly available ClickHouse and Altinity cloud. So it's just host, port, and yeah, user password, as you can see. And yeah, actually we can run cube.js with just npm run dev. This is just one of the ways to do so. Typically in development environment, you can run cube.js through npm, or you can use it in a Docker container, and in production, of course, you'll be running it as a swarm of microservices in Docker. So yeah, cube.js is now running in development mode and is available here. So let me open my browser and see what there. So yeah, this is a web interface called cube.js development playground, and actually you can it can bootstrap some schema for you based on what tables are available in the database, but I won't be doing that. Just to prove that everything that I was showing to you is correct, I'm just go to my slide and just copy the data schema from here and paste it to the file. So yeah, I'm gonna stop cube.js and just add one file here called, let's call it GitHub events.js, and here it is. I'm gonna save this file, start cube.js once again, go to my browser, reload the page, go to the build tab, and yeah, you can see that measure definitions and dimension definitions and segment definitions are available here. So let's just construct the same query that I was showing to you right here through this web interface. So let's say that we need only a subset of data regarding pull request commands that we want to count an approximate number of users, and we want those users to be sliced by pull request URLs. So yeah, this query is running, and we can see yeah, in the console that we have some progress here. Yeah, here's the result. So actually we can compare. So let's see what's the topmost result. It's Linux pull request. Oh yeah, 684, and the same result here. So probably it's not really that fancy to see some web interface over a database like running, but actually what we're doing here is just composing this cube.js query in a JSON format, which says, yeah, we need user count, we need to order byte, and also we need just pull request URLs in this like segment of data. But cube.js generates the SQL based on that JSON query, and as you can see, it's pretty much the same as we saw in Alexey Milovido's blog post. So cube.js is able to figure out how to generate SQL, and believe me, it can get even more complex now than that. So I believe we have some time, so I'll show you some more things we can do here with cube.js schema, just so we're not only copy pasting things but also developing something. Yeah, it's always great to develop things. So let's say that we'd like not only to know the number of users which made those commands on those pull requests, but also the actual number of commands. So let's introduce just one more measure called count, and all we need to say that is this measure would be of type count. And also, as we are going to know for every pull request the number of users who commented and the number of comments, let's see if we can count the ratio between those two measures. So this concept is called like calculated measures, and yeah, probably it's also not that hard to compose this measure. So yeah, I'm gonna say SQL, and of course at the type it's gonna be numeric. Yeah, and I'm just say that I want this count measure to be divided by this user count measure. It should work, I believe. So I'm just saving this data schema, exiting, rerunning cube.js. Actually, cube.js is pretty much able to sense the changes in data schema and get them without me reloading the app, but I'm just having this single terminal window here. So yeah, I'm just so yeah, okay. So I'm gonna reload this web interface and see if we have our new measures. Yeah. Yeah, we have count and ratio here. So I'm gonna switch to table representation of the data and just add some more measures to my query. Yeah.
Hey, you've got some questions coming up both on YouTube as well as in the chat. Do you want to take them now, or do you want to do them at the end of your talk?
Well, actually, the end of the talk is just in a few minutes, so I'll just finish and answer all the questions. Yeah, thank you.
All right, hang on, everybody. We'll get to you.
Yeah, okay. So I'm just adding these new measures here, and let's see what we'll get. Yeah, it says that the query is quite complex, and ClickHouse is trying to crunch data right now. But yeah, actually we are done here. So as we can see, those famous pull requests in the Linux repo, which involved 66 people commenting, it contained 83 commands, so the average ratio was 1.25 commands per person. So yeah, that's it, and let's get back to. Yeah, no, that's not all. Probably the last thing that I'm going to show you that through this demo is that not only you're able to click buttons in the web interface, but actually you're able to send those queries to cube.js through its API. So this is just a development environment, but what would you do with cube.js in your development workflow is to run it and then query it with from your front-end application or a mobile application or just a standalone dashboarding app. With those queries, just send them through HTTP using provided client libraries and get the results back. So here on GitHub, in the cube.js repo, I have just the same example that I started my talk with. So it was, yeah, there's that ClickHouse dashboard, and I'm going to show you like in the wild how interacting with cube.js on the front end might look. So this is just a standard like React application, and as you can see here, we just in this file we just instantiate a cube.js API client library. We just pass a URL here and just a security token, and we say, hey, yeah, let this API be available down the component tree of our React application, so every component can just query cube.js. And I believe just right here. Oh yeah, we have such a React component, just a huge component which actually draws our that stock market chart, and there's a lot of like React code here, but the code which is specific to cube.js is just like a few lines. So we import this React hook, which is called use kube query, and in any part of our application we can just put a query inside it. So this is a query where just a single dimension is needed. This is equivalent to saying select like distinct with some SQL expression and get the results. But down here, we also have a much more complex query being sent to cube.js with 4 measures and a time dimension, which is used to calculate those measures over with some given granularity and over given data range, and also some filters we can introduce to modify the result set here. And here the filtering is done on some dimension, and it can be more complex than that. But as you can see, there is no SQL here, and all definitions for measures and dimensions are stored in your data schema. You can reuse them and to build more queries and maybe to build just another application talking to the same API. So that would be it for the demo. Let me return to my slides, and I have just a few of them. So we were not like diving deep into the performance of all of this and how cube.js can help you with the performance of your queries running against ClickHouse. I surely can, but I believe the ClickHouse community is not that concerned about performance given ClickHouse great capabilities in that area. But with cube.js, you can supercharge like your client applications talking to ClickHouse with data schema, which will allow to reuse your business-specific, like domain-specific definitions for measures and dimensions, and cube.js will generate your SQL queries for you. And on top of that, you'll get like for free and like in minutes, an analytical API, which you can integrate with your applications, for example, web applications, and no matter like what front-end framework you use, or maybe just you'll be talking to that API with some raw HTTP requests. It's also possible. So that's it. And if you need anyone's word, like except for mine, that cube.js is great, let's see that in the same GitHub dataset, Alexey Milovidov endorses cube.js and says that it's one of his favorite, or he just slapped a star to our repo in 2020. So yeah, that's all for my talk. And I'll be happy if you flick through this ClickHouse guide that I've written on dev and have a look at demo app. Definitely give cube.js a try and see if it can blend into your like data pipeline, if you can use it in your application to get an API for free and to get reusable definitions for your business entities through data schema. Don't hesitate to join Alexey Milovidov and give cube.js a star on GitHub. And I'm very much looking to your success with ClickHouse and cube.js. Feel free to ask me any questions. Thank you.
That's a great segue because we got a bunch of questions. Let's go grab the YouTube ones.
Okay.
So let's see. Here's a great one from Dimitri. Can this product be integrated to other web pages, and does it support interface customization? I think you kind of touched on that, but
yeah,
maybe,
but I'm going to double down on that. Actually, like probably the most important feature of cube.js it is being like visualization agnostic. Like, though I was showing you some web interfaces like cube.js developer playground and so on and so forth, cube.js provides you an API, analytical API you can talk to and to query your data. And it's up to you how to integrate that API into your app. We like in open source with cube.js, we provide like a lot of client libraries and integrations and wrappers and components for different like front-end frameworks, but it's up to you how to integrate it with your app and how to visualize that data. If many development teams that integrate like cube.js and their existing applications, they are amazed that they can make it look native to their apps. And so the interface, the charts, the metrics, how you visualize them will look just like you want them to, and cube.js will be just serving your data through the API to the web application. Hope this answers the questions.
Yeah, that's great. I had the same question, so I'm really glad that Dimitri asked it. Let's see. Here's another one. Let me get the question from my friend Kurt Collison. Hi, Kurt. If the goal is to be more human readable compared to SQL, I'm not sure this DSL is much better. So do you have a response to that? Because what do you think is the trade-off here between the details of SQL and the details, for example, of JSON?
Oh yeah. First, I should say that I'm not a big fan of this like JSON like JavaScript like statements that that is used to describe the data schema. But I would say that yeah, maybe they are not that beautiful, or maybe not that concise compared to just a single SQL query. But if you take broader perspective here and think not of a single query being just represented as in parts in cube.js data schema and then generated to SQL with cube.js, but if you think of like dozens of queries which are probably needed to be run for your application to exist, then it will really make sense to decompose those queries to dimensions and measures, like in this OLAP fashion, and to reuse them from the data schema. Yeah, maybe every single like definition will not be that pretty with some backticks and and all this like things which come from JSON notation, but what you get with that is the ability to, like as I said multiple times, to reuse the schema, and to also, I didn't like dug deeper into this, but also to apply some performance optimizations, which are only available if you say, this is my dimension, this is my measure, this is just a set of dimensions that I query frequently, and yeah, cube.js actually also provides like a multi-level caching system, which heavily relies on the data being described through measures and dimensions, not through like some arbitrary SQL statements run against your database. So without data schema, that wouldn't be possible, and so probably the price we're paying for that is not that much.
Okay, so next question off coming off YouTube is, does cube.js also support joins on ClickHouse?
Oh yeah, of course. So like in principle, cube.js supports joins, and you can define them like in pretty simple, in pretty similar fashion to that one using SQL. You just say, is this cube, which is modeled over a table, that cube modeled again over a table, and to join them, you just use this SQL clause, which says which columns should be joined from one table with another, and also you specify just a relation, yeah, like one to many, many to many, and so on and so forth. And what's more important is that with cube. Again, if you're not unhappy with the performance of those joins, cube.js can apply its two-level caching system to pre-aggregate or materialize your data, or data required to the data that you'll be querying from a database with this complex like SQL query with joins, and it'll make the results available just in sub-second response time, because it can do it like ahead of time, and when you do the query, the data will be already joined and kept in a refreshed state, and cube.js will be able to serve that. This is just how pre-aggregations in cube.js work. And probably another thing worth mentioning here, is that cube.js can even allow you to run cross-database joins. So in this talk, like in my demo, I connected cube.js to just a single ClickHouse instance, but what I could do is to connect it also to a Postgres and a BigQuery and an Azure SQL database, and define different cubes or model different cubes in the data schema over tables in those different databases, and with dimensions and measures defined in those schemas as well, I would be able to say, hey, cube.js, build me a pre-aggregation over the data in these different databases and store it somewhere. Well, there is a nice place to store them. It's called Cube Store. This is just a very highly specialized data store written in Rust, which is used by cube.js, and it's also open source. But yeah, I would say, hey, run a pre-aggregation. So this cross database join or query, which requires this cross database join, can be run against cube.js, and it could be the results could be served again in a sub-second with sub-second response time in operational fashion, and it'll work. All because being able to connect to different databases and being able to reason of data in terms of data schema entities.
Got another YouTube question, and then we have one in the chat as well, which we'll get to in a second. From Andre, is cube.js an alternative for Apache superset? Maybe you could just compare those two if that's a reasonable question.
That's a great question, and the short answer is totally not. Like Apache superset is I would say a data exploration or data visualization tool, which you just run standalone and use it to connect to a data source and to create some visualizations. Usually you don't want this Apache superset to be a part of your application, the application that you are building, and this is where cube.js shines, because for quick data exploration, like for data analysts and data engineers, it would be easier to use supersets or other data exploration tool to slice and dice the data. But if you're an application developer and you have your data residing in ClickHouse, it would be better for you to just bootstrap an API to query the data, and this is when cube.js is particularly useful. So cube.js is not competing with superset here. I would say that superset might be complementary to cube.js, because like cube.js developer playground, which I showed you during this talk, it's not that complex, and it has less features that superset can provide. So probably in some complex scenarios you would like to explore your data with superset, than to build data schema, model your query, and to double check that the result set that you get is correct via cube.js developer playground, and then use that cube.js query in your application, just copy and paste it to your front-end application code or something like that.
Cool, thank you very much. And since you're not competing, you won't mind if I mention that there are some improvements coming to the Python SQL Alchemy driver, actually ClickHouse SQL Alchemy specifically, that'll make superset work better. It does bring up a question before we ask, before we get to the next question, is did you find any problems with the JavaScript drivers that you're using for ClickHouse, or any other issues with ClickHouse that we could help you fix?
I believe I'm not aware of any issues with those drivers. It's open source, so
are you guys using Appla for your underlying driver?
Let me double check, so I don't mislead you. So yeah, here's the ClickHouse driver, and let's see. Here's the actual file. Sorry, did everything right? Okay. Yeah. Okay. I would probably just go to check the package.json file. So here are the dependencies. Yeah, we use Appla, and I'm not aware of any issues with that. The only, actually, it's really nice, and I believe that we in our driver we are just doing some some simple translation of options when connecting to it. So this is actually an Appla config, and also we needed just to let me show you. We needed to just add some really simple SQL statements here to adapt to the dialect. We actually have some dialect definitions in a separate file. But anyway, it's not that complex. I'm not aware of any issues, but if you'd like to contribute to this driver or to Alpar or to cube.js in general, you can just go here and I'm sorry, guys. Sorry, folks. I was thinking that I was sharing my screen, so I was flicking through code and actually looking for alpha there. But yeah, anyway, what I just wanted to say that yeah, you can feel free to go to cube.js repository on GitHub and flick through the issues there and look for ClickHouse there. And if there is something something which looks like an issue you'd like to tackle, definitely do that.
Great. A question from the chat. Paulo has been waiting very patiently, or he was. Cube.js could Cube.js be used as a connection between data teams and developers, for example, to standardize how the applications consume data?
I would say yes. Yeah, it definitely depends on how your company or your development teams are structured. So yeah, in a scenario where there is some kind of data team which owns your data lake or data warehouse and which is responsible for ingesting data there, organizing it, and all things related to that. And there is another team development team which builds applications on top of that, like data lake, data warehouse. Yeah, it would be correct to say that it might be a shared responsibility of both teams to generate or to create a data schema, or at least to come to an agreement what is the shape of the underlying data, so it doesn't change if your data schema refers to that. But having said that, I would say that yeah, cube.js would be their go-to technology for a development team to bootstrap and launch an API on top of that data lake or data warehouse and make their application to talk to that API. So it's really an open question who should be responsible for the data schema maintenance. And as you can see, as applications developers, you would most probably like the measures and dimensions to be modeled by you in terms of your business domain. But if your data team is also up to doing that, give them a try, or just share the responsibility for the data schema between the teams, and then use the API to build to build your applications.
Cool. I have a closely related follow-up question from our YouTuber. Do you have a GraphQL backend or plans for one?
Oh, that's a brilliant question. We actually have an issue on our GitHub, or this time I'll be sharing my screen. So yeah, let me try to find that. I was expecting to find it here. Anyway, so yeah.
Let me find the post on the forum. I moved it to our forum. That's why it's closed on the issue. But
yeah.
I'll find the post and post a link here.
Yeah. So we have an issue on GitHub, and it was actually me who created that issue, which files a proposal for the cube.js team to think of having a GraphQL-like syntax for its queries. And I would say that, personally, in my opinion, it looks very promising. And I would as a developer who is involved both in data engineering and data visualization, I would very much like to have some alternative syntax for cube.js queries, like GraphQL syntax would be nice, because if in that case it would be really easy to use cube.js alongside tools like Hasura or Apollo to query transactional data or document or data which is like stored in the shape of documents through this GraphQL backends, and also to query analytical data through cube.js using like the same shaped queries. Maybe it's not that big of an issue because like those JSON cube.js queries that I've shown you, they're not that you know, hard to write, or maybe it's relatively easy to get like auto completion for them. But anyway, like if cube.js gets this kind of GraphQL alternative syntax one day, it would be nice, I think. And yeah, thank you, Ray, for posting that link. Feel free to join the discussion on our forum, or maybe work with us with cube.js team to implement such a way to write cube.js queries. Yeah.
Cool. You know, we're kind of running close to, I think I had set this for 90 minutes. We can stay for a few more minutes, but we've hit all the cube.js questions that were pending. Denise, if you can hang out for a few more minutes, if there's any general questions on ClickHouse, we'd be happy to answer them, or you can ask Igor or Abe. Let's see, Abe is still here. If you have any more questions on any of the talks, just feel free. And we'll give it 10 more minutes. We're kind of losing our viewers. So,
yeah, I will be happy to answer questions if they arise, and also like to take note, I shared the links to cube.js on the website and GitHub repos, so you can dig deeper and explore.
Thanks. I love both these projects. One thing I wanted to follow up a little bit was you said something really interesting, which is that you could help with concurrency on ClickHouse, and that's interesting because it's kind of a high, you know, ClickHouse is not designed to be highly concurrent. It's designed to just grab all the resources and to run these enormous queries. So do you have any experience on how people are actually using that in actual applications? Maybe some that would, see you later, Abe. Thanks.
Well, like the most, like the usual use case would be just to make your web application run queries directly against cube.js, and cube.js will then use its caching layers to make sure that only let's say only few of those requests hit the actual database, because they are cached like using pre-aggregations, which can be invalidated based on some conditions on your data. Even when new data comes, it can be revalidated, or based on some or it can be like invalidated every few seconds or every few minutes. And cube.js makes sure that it serves like fresh data every time, but ClickHouse in our case will be hit only when the data changes. So if you have an application where tons of users are just running like similar queries based on the same set of dimensions and measures and filters, most likely they will be served from cache, from like be it in memory cache or pre-aggregations, and those ones would be kept in up-to-date state asynchronously from just this process of querying the data. So this is how it works, and I believe that probably this might be the way to add high concurrency to your applications using ClickHouse.
Cool. Yeah, I definitely like to understand that better. I'll check with you offline. We have actually a general, oh, I love this question. This is a general ClickHouse question. There's another cube.js one. So here's the question, and we have several data sets from 2 terabytes to 2 petabytes of financial data or financial stock data. There's a video from previous sessions that explain the approach when the hot data is stored on the fast disks, the warm data a bit slower than the historical data stored in the data lake. Can you please briefly explain how it is implemented and how it will be will it be a single table logically when you query it? So these are this is multi-volume storage. I think, and Denise, I'm sure you can chip in more, but I'll just give you the overview. Basically, what ClickHouse does is it allows tiered storage, and so you can define volumes, and then the volumes can contain multiple disks, which are just mount points. And then you can have what are called TTL moves, so time to live moves, where you put a condition on the data that says, that's actually written into your schema. It says, hey, after 30 days or after something that, for example, is computable from the row of the data, move it to the next volume. So the idea is that, and we have a pretty big blog article, several blog articles on this and presentations, but first of all, it's a single table. So you can do queries, and ClickHouse will go fetch all the data regardless of which tier it's living in. 2, it will automatically move between the tiers. And so the TTL moves are probably the most popular way, I would say, because you can reason about their behavior from things that you can see in the table. There is another way to do TTLs, which is just based on how full the disks are. Those are more transparent, and it's a little bit less predictable how things will move. But that's the basic way that this works, and it works pretty well. There's a number of production installations using this. Denise, do you have any other comments on multi-volume storage?
No, basically that ClickHouse table, it's a set of small parts of partitions. So you basically, when you create a table, you explain ClickHouse how to separate data among partitions. So you can partition by month or by day or by week, and doesn't matter, or any custom expression on the columns. And after that, when you query, for example, the today, ClickHouse reads only the today partition. It reads only a small subset of data, and using TTL moves, or you can actually don't use the TTL rules, but you can move, for example, using own solution, and you can run by cron, for example, the command, and this command will move the old data, for example, when you're happy to move it to cold storage, and it will move to cold storage. And but when you query the same table, you don't need to rewrite query. You just run the query, and if you query the partition which is lays on the cold storage, you will get data instantly. That's all.
Yeah, I would say that it's really nice that ClickHouse abstracts the way the data is like modeled from the way it's actually stored, which allows us to
Yeah, that's exactly right. So you don't, and as Denise says, it's really thinking in terms of parts. There is one other thing that's kind of like the next frontier, which is to make this run fast in object storage. So that's object storage is supported as a tier. It's not super quick. There's definitely some stuff. Okay, let's do 2 more questions. There's a question from Chris Leonardo for Igor. Are there plans for TypeScript support in cube.js?
Well, yeah, there are such plans, and I would say that just right now, cube.js is like written in, at least in part, in TypeScript. So it's JavaScript, TypeScript, and Rust mostly right now, and there are major parts written in TypeScript. So you can just, it's open source. You can go on GitHub and see which ones. Also, yeah, we are going to introduce like better support for TypeScript and for typings, in maybe in data schema definitions and in drivers and so on and so forth. You can definitely ask for more details just through our Slack, which I'm sure you're on, because like I just can't remember that by name. And yeah, that's it. We are definitely looking for more like TypeScript exposure to cube.js database and for you to be able to write data schemas with TypeScript. And if you have particular concerns, just share them, maybe through Slack, maybe through forum, through other means, so we can think about supporting your use case as well.
Great. Okay, so I think that covered. So Chris, it sounds like there's some stuff to go look at. Let's take one final question because we're fairly far over time. I'm going to take this. This one's a kind of an interesting. It's from AB. He says, or she, I love ClickHouse, but without transactions, it's a blocker for me. I store a great deal of data today and update the payload several times per day. Druid guarantees atomicity per segment. Is there an equivalent in ClickHouse? Let's see. So Denise, you may have some insight into this, but I can tell you that, okay, so there's definitely some work to be done on transactions in ClickHouse. And I think two places that that right now the fundamental unit of transaction is the part. So when Denise mentioned that when you write a part, it either happens or doesn't. It's atomic at that level. Where you get into trouble still with ClickHouse is if you have to write parts in two places and or like two parts. And this could happen because you've got a big insert which extends to multiple parts, maybe because it gets split by a distributed table, or if you have an insert that then gets pulled to a materialized view. Right now, ClickHouse does not guarantee consistency between those, so it's not ACID. So the materialized view problem is getting fixed. I think, Denise, do you know when that is supposed to drop? I think that's coming in the spring, correct? Is that, or do you have a, that's what
I
Milvidov
saw
said
it on
the last time we talked.
roadmap, but I don't remember any actual work on it. But so maybe the second quarter or maybe third. But yeah.
He was
But
Milvidov.
it's,
Yeah. Okay.
yeah. It's if you need actually atomicity, sort of atomicity and consistency, it's doable. It requires sort of proper development, but it's doable because actually replicated table has they are idempotent, and you can repeat inserts, and you can actually create materialized view in such a way that inserts will be idempotent for them too.
Right.
So if for example your insert fails because of I don't know, zookeeper issues or something like that, and if you repeat insert, and it will be, the data will be consistent. I can do it. Yeah, I have actually system in production for more 4 years, and the data is completely consistent in Vertica and ClickHouse. So I have like 4 data warehouses in different part of planet, and the data is consistent to single rows and we have like 400 billion rows, and the data inconsistent in all tables and all materials that we use, and in all tables and Vertica and ClickHouse. So it's doable, but it requires a lot of development. Yeah.
Okay, so that sounds like something we should probably do a post on to explain that idempotency, because it's definitely that, you're absolutely correct. So for people who don't know it, Zookeeper does track your parts and well, specifically blocks, which are basically parts, and if it sees one come up again, it won't insert it, which means sometimes actually if you insert the same rows twice on a replicated table, you'll only see them once, which can be really confusing, but that's dedupe in action. I think that given the time, I'm going to go ahead and close. Igor, thanks again for doing a great talk. Definitely looking forward to, I'm going to hop over and put a star on your project. Thanks, Denise, for coming and hanging out with us. Denise works with us as a support engineer and also runs other systems as well. And thanks to everybody both on Zoom as well as YouTube. It's been great having you. We'll do another call in another a meeting in 2 months. Please hit us up with topics. We've already got one. Somebody wants to see learn more about Kubernetes. Here's a quick question. Let's do one last one. Can we query data in S3 and Parquet recursively? We'll answer that question and then we're really going to go. We don't have it. Do we have recursive queries in S3? I don't think. No, we can't do recursive CTEs.
Well, I'm actually not sure what. I'm just got confused with our recursive
Probably
queries.
it's about ClickHouse, not about.
Yeah.
Yeah.
No, ClickHouse doesn't have recursive CTE, and actually. There is no good way to implement it for big data for OLAP, and yeah, right now there is no plans to implement them.
Okay, there's an answer. Yes, you can use the wildcard in the S3 path. Okay, we're gonna pick that up. We're gonna pick that topic up at the next meetup. Thank you everybody for attending. It's been wonderful having you, and have a great day. This is recorded. Keep an eye out for it. We'll also post the slides. Igor, if you can send me a copy, I'll get them shipped out to everybody that signed up.
Cool. Thanks for having me, and you have a great community. Let's thrive.
Yeah, it's a pleasure. Thank you all, and have a great day.